In Part 5 of this presentation about sustainability, we will discuss various scenarios for the global mean temperature in the future. It will be shown that the carbon dioxide can increase as well as decrease, depending on the selected carbon dioxide management activities. Furthermore, a few approaches to take carbon dioxide from the atmosphere will be reviewed. Applying similar calculations as shown in Figure 3, 5 scenarios have been developed. This figure compares these 5 scenarios. It is assumed that till 2030, each of these will be the same. The first scenario, called business as usual, BAU, extrapolates the current carbon dioxide emissions data till 2050. The Shell scenario is based on information published by Shell about global warming. The most aggressive scenarios are called plausible, and drawdown, based on the published book by Paul Hawken, see reference 21. My proposed scenario, indicated as author's scenario, is selected as an achievable compromise. This is based on my experience, and discussions with colleagues in industry, R&D institutes, and universities. A comparison of the 5 scenarios is listed in Figure 38. The table shows that the Shell scenario still increases the carbon dioxide in the atmosphere by 351 gigaton, relative to 2020. To achieve notable carbon dioxide reductions, the author's scenario, or the plausible, or the drawdown scenarios should be considered. A summary of the water and carbon dioxide concentrations in the atmosphere is shown in Figure 39. The corresponding global temperatures and greenhouse coefficients are listed as well. Applying the author's scenario would reduce the global mean temperature to 14.2 degrees Celsius, close to the Earth's temperatures between 1990 and the year 2000. Applying the plausible or the drawdown scenarios would leads to temperatures colder than the global mean temperature in the year 1850. At 14.2 degrees Celsius, ice creation at the Earth's north and south poles would probably start again. Decreasing the carbon dioxide below 300 ppm could harm agricultural activities, which is not desirable with an expected growing global population. Figure 38 shows the carbon dioxide by sector in the atmosphere in gigaton, comparing 2020 and 2050, and applying the author's scenario. The data indicate that most progress is expected in the electricity, agriculture, and transportation sectors. A key assuming is that the water in the atmosphere will be close to the average during the years 1880 till 2020, which seems to be a reasonable assumption, but it does depend on non-controllable solar activity in the future. Photosynthesis is the natural way to remove carbon dioxide from the atmosphere. About 25% of the anthropologic carbon dioxide is absorbed by photosynthesis. This enables the growth of trees, flowers, grasses, etc., and agricultural activities. This requires that the atmosphere contains at least 150 ppm carbon dioxide. If one uses soil, with enough water and minerals, the optimum carbon dioxide level is estimated to be 1,500 ppm. For this reason, farmers and gardeners add carbon dioxide in their greenhouses. Biochar is an emerging carbon material derived from renewable resources, for instance, biomass, agricultural crop residues, and livestock wastes. This has created great interest based on its broad practical applications in a variety of areas, covering carbon sequestration, and potential soil amendments, see reference 26. This figure shows a commercial biochar plant, and an enlarged picture of the biochar product. Trees and plants do grow faster in sandy soil mixed with clay, biochar, and mycorrhizae fungi, if one has enough water. This had been demonstrated successfully, in many areas around the world, that have very degraded soil, for instance in the Gobi Desert in China, and around the Sahara for the Great Green Wall Initiative. To date, the most widely accepted method of carbon capture and storage, called CCS, is the injection of carbon dioxide into underground, geological formations and reservoirs. These are many times located offshore, and at considerable distances from a fixed point source of carbon dioxide. Therefore, the risk remains that potentially, suitable reservoirs may turn out to be insufficient, uneconomic, or impractical. Carbon capture and mineral carbonation, called CCMC, also called carbon dioxide mineralization, has been identified by the IPCC as a possible promising additional technology for the removal of carbon dioxide from the atmosphere. CCMC is a process, shown in this figure, whereby carbon dioxide is chemically reacted with calcium and/or magnesium-containing minerals, to form stable carbonate materials, which do not incur any long-term liability or monitoring commitments. The IPCC also highlighted that this approach is highly verifiable and permanent in nature. It is therefore likely that CCMC will be enjoying greater acceptance than the traditional geological CCS approach. Several industrial companies are pursuing CCMC, and demonstration pilot plants have already been in operation. See the reference at the bottom of this figure. In Australia, one recently discovered large deposits of halloysite kaolin clay that can be uses for CCMC. Biochar plus carbon dioxide mineralization can potentially remove about 78 gigaton of carbon dioxide in 30 years, as estimated in the book of Paul Hawken, see reference 21. Star Technology and Research has designed a system with space mirrors that block sunlight from reaching Earth and can provide another source of clean energy to be used on Earth. See the picture on this figure. The company proposes launching several hundred of these spacecrafts into orbit close to Earth. These spacecraft mirrors can be remotely controlled, while reflecting sunlight. In addition, the spacecrafts would be equipped with solar panels, which would collect some of the sunlight and send the captured energy back down to Earth. But geoengineering has many potential pitfalls, which have not made it popular with scientists, whose climate platforms focus instead on ways to reduce the Earth away from using fossil fuels.